So let's start our conversation. We'll focus on quantitative research methods and the inferential techniques using SPSS. Am I audible to everyone? Okay. So this will be, as I told you, that it will be very basic things we will discuss, and but it is basic, but at the same time it is also a very powerful tool to communicate our research among the community, also to the different stakeholders who might be using our research. So what is why we use statistics? Statistics is a science. Though if you have seen that many of the departments, they use MSc statistics, BSc statistics, because why this statistics is based on the scientific reasoning that everything has to be collected in a scientific manner and validated through the appropriate tools, and the general conclusions drawn from those observations using different tools and models will be used universally. So basically the statistics has three components. One is to collect the data, analyze them, and then the very important part is how to present this data. Means you have several observations, you are grouping them, then you are deriving some patterns, trends, you are looking at the relations, strength of these relations among different variables, and then you are coming out with few numbers. So those numbers are also has to be presented in a manner that it conveys the message we intended to communicate to our research, to different stakeholders in the research community. So yes, the final outcome of any such exercise is to formulate policies and make effective interventions in various fields. So basically, some of the areas which highly use these techniques, of course, the different streams of science, medicine, economics, and also designing different welfare measures. So the numerical evidence is today called the data economy, or the age of data, and that with data is the power also. Data gives power to formulate policies. Data gives power to also to bring address several challenges in various sectors of the economy. Without data, we cannot continue our modern way of policy making. So first, I told you that formulation of research, but the thing is that statistics itself, when we come, since most of you are economics and economists, and I myself is also from economics background, though I practice multidisciplinarity, but I cannot claim that I am not an economist. So that background, if we take, there will be some bias in my interpretation of the things, but those who are from other disciplines, you can also get the message and look at the message in the context in which you are working. So these are the general things which one has to follow in any kind of research, any stream of research one is interested into or engaged into. So first is how to define the problem and fixing research questions. See why this is very much important, because you may be acquainted with several tools, few of which I will discuss. Generally most of the classes like this, we refresh our basics in this kind of engagements, and when one is really interested in the discipline, they can go deeper into the subject, and there will be thousands of techniques and methods one can come across. But when to use those techniques and methods, one has to define the context in which they want to use it. Now that context can be understood if we have understood the context, what is the purpose and why we want to do pursue the issues involved, and in that context defining the problem and fixing specific research questions are very important. I am sure there will be certain sessions in your program which you might have already attended or you are going to attend in coming days, on how to formulate research questions, how to formulate research propositions, hypotheses, and how to, for that, literature review is very important to understand the area specific. So those kind of things will be dealt by the different experts, and everything is integrated. Nothing in program like this, you have to think that all the components what you are being taught here or what is being discussed here, everything is interlinked. So maybe I am starting from defining the problem and fixing research questions with the assumption that you are already exposed to that issue, or in coming days you are going to be engaged in that. So that literature, the knowledge of the past work, research work in the context you are interested in is very much interested, and that is the stepping stone for your coming statistical exercises and getting the meaningful results. So in that context, this defining the universe of your inquiry is very important. From that, what follows is the sampling. So sampling has to be, one has to be very careful about the samplings. Sometimes we understood one, especially if it is a student or a practitioner, that based on the budget we fixed some sampling and we collect some information, whether it is at a household level or individual level. Then we come across, then we found that nothing significant is coming except for few frequencies and general things which already is known. So there is no innovative or path-breaking outcome is coming. Why? Because that is depends upon how you have defined your research questions and how you are going to address the research objectives. Based on research objectives, what are your context variables you have chosen to work with, and once those variables have been identified, how you have set up your plan to collect information for those variables. So then after the data collection, the next thing comes how to enter those data. If one is using SPSS or Excel or Stata or any statistical software, everything has a kind of, though broadly similar, but with some minor differences, kind of how you enter the data. So that is very crucial. So sometimes what happens, lot of information we gather. Earlier mainly the paper-based tools were used, but now we are using mostly the mobile and other software-based tools which has hastened our process. So by most of the current research agencies, they are no longer using the paper method. So they are going to mobile device-based information gathering, and the software allows the data to be directly poured into your worksheet or spreadsheet. So this is this way, but otherwise many people cannot afford those kind of things. Still the data needs to be entered in a proper format. For that it is very much required to understand the software, how they intake the data you are entering, the information you are entering, depending upon the nature of the variables and the kind of responses you have received. So then the next phase where the statistics is going to take over is the analysis of data. So we start from the descriptive interpretation, then we have use some inferential techniques, and that inferential techniques here will be coming across lot of modeling techniques that starts from one variable scenario to bivariate scenario to multivariate scenario. Then we interpret and results and present the findings. So with that, so we'll spend some quick time that I'm sure that how many of you know the sampling techniques, sampling and sampling techniques? Okay, many of you, so no. So we'll not spend a lot of time in that, but still we'll quickly, for those who are not well versed, many people think that the sampling is very important only in context of economics or quantitative research, but it's not like that. Even if you are taking a qualitative research or observation method or anything, case studies, there also you have to do a lot of groundwork to understand your universe, to understand the stratification in that universe. And suppose if we are talking about a rural village area, so one has to understand what are the different social groups are staying there, what are the dynamics of those social groups, and how the resource base has been occupied or resource base has been accessed by different groups. So based on that, you do your stratification. Then from stratification, from each data, you choose a sample that it represents overall the village population as well as the inherent characteristics of that population. There are also the clustering sampling method where it is instead of we select individuals from each data, we can also be we are dealing with the collection of subgroups and treating them as a kind of unit in the sample, broad sample. So when there is a large universe is we are dealing with, we generally go for the cluster sampling. So this is kind of a graphical presentation of how, what kind of because since many of you, anybody wants more focus on the sampling techniques, sampling. Okay, so sampling, that part is clear. So that's why I just one slide I am doing that. Then we can look at actually what kind of variables we deal with. So the two broad categories of variables we dealt in the research statistical, our question in the statistical application is the scale variables and the categorical variables. So the scale variables can be continuous as well as the discrete variables, means without integers. So then the categorical variables, which we know it only identifies, it is only a nominal identification of different categories, and sometimes we can have the ordinal one and sometimes it is purely nominal. I have given the examples. I think we everybody is familiar with this. So anybody is telling something? Okay. So this is the thing that it is in context of SPSS, when you enter the data, you have to be very careful about how to define your rows and how to define your columns. So the data cannot be in a haphazard way, it has to be entered. So if you have, let's say, you have a gender characteristics you are entering, you can choose either using numerics to identify the groups. So then the code book is very important. So that is many of the statistics work. Many people do not realize it, the data, what is the most important thing when you do your analysis. It is your code book, because code book is kind of a black box of your data what you have collected. From that you can know that at what level you have collected the data and how you are going to enter those data and what analysis can be planned based on that. Sometimes again we see that even some coding can be also done. Some variables also need some reports. So there are a couple of ways to report the variables. So that also helps transferring the variable, let's say continuous variable, into a categorical one or a ordinal one. So that's why in SPSS at least, which I am sure if those who are using other like the Excel or Stata format also, if you choose to enter data manually, so you have to be very, very careful that you should have a ID variable which will which should be unique for each of your units of data collection. Suppose you have collected data at household or individual level, you can have a one ID. But suppose you have collected data, let's say, across villages, blocks, states. So each of these identity, that is called the household identity variables, has to be to pinpoint that household from where this household was picked up. So you have to create an ID. So in many of the data, those who have used NSSO or NFHS or other large-scale national surveys, you will find a very big number for an ID variable. Actually, that number is not, they have given some number to it. There is logic behind it. That they have at least gone from state to sub-region to block to panchayat level, then village level, then the household level. So each one has been given. So that part I am not dealing here in detail, because creation of ID also sometimes many of the softwares we are using now, they also can create a unique ID for each of your row variables. Okay, so can you tell me now that if your ID variable is identify the unique observation in columns or rows, if you are clear in that, then life is very easy for your data. So how you enter ID variable, how you create a ID variable. So it has to be a single column variable. Okay, where even if you are using different information to create one single ID. Suppose I have given only a subject ID because I have collected few households. This is part of a real fieldwork. So some of the sample variables I have collected for our practical purpose. But otherwise, why I choose just this 1, 2, 3, 4 kind of thing? Simply I have given it because it is a very small sample data, and I don't have to control because it was collected from one village. So I have not given so many layers of identity variables. But if you have several layers of identity variables, then either you can choose the automated process in the software to create a unique ID for each one, and then you have to be very clear that if you are, let's say, for both household and both individual, you have collected information. Suppose in household you have collected information for more than one individual. So in that case also what you have to do, that your household ID as well as your individual ID cannot be same. It has to be different. Okay, so that you can locate a particular household and also you can locate a particular individual within that household. So these things are very, very important when you do your statistical analysis. So the ID creation, the thing, crux of this presentation so far is that the ID creation is very important. How you are creating your ID variable is very important. When you are going in your analysis process, suppose you want to split the file, you want to merge the file, so how you can do it? You can do it, if it is a small sample data, let's say 300, 400, 500 even, you can handle it. But if it is in thousands or lakhs, then this is the ID is the only way how you can deal with it. Have you any, is in this audience anybody have already done this thing? They have merged the individual household file in SSO, in NFHS. Anybody have done that? Majority of them have not done that. Maybe in the next thing you can see that how you can do. Did you get?
Yes, sir. Yes.
So just remember the PPT number where we went till now. So 5th, no? Okay. So I'm opening this file. I can show you. You see. So you can also practice if you have already got this, but there is only single file, so there is you cannot merge or with it. you can actually go to transfer. In transfer, if you see that there is record and other things are, then you go to data. See the data. Those who are not familiar, it is for them. See, here there is something called merge files. So this part I will include in the PPT when I will share with you, because I thought that it will be already too many slides, so to reduce I will not include it. So if you see this, there are two ways of doing the merging of files. This is very important. I am only taking the case of household and individual. If you suppose you are merging two files of households only, means households from one village with households from another village, then you can straight away use the R cases. There also the case ID, see what you can do when you can browse another file here, take it, and if you open that file, so it will give something to merge. Okay, so here when you do this part clearly, because we are dealing with one file, so it may not be convincing for many of you, but when you go to add variables, you there also first you select the file, and also you have to identify. It will ask what is the ID number, what is the ID number you have. This unique ID, based on that unique ID number only, it will add the number of variables you are taking to another file and creating a kind of a consolidated file. So that part will deal with it, merging of the cases, and then return to our main thing, that suppose we are dealing with what is happening, some problem.
Yeah.
So where were we? So data and variable. So so that another. So next thing which is very important, I told you, is recoding the variables. See, in our sample file, if you have already got it, the sample file I have purposefully kept two continuous variables. Sometimes if these continuous variables are useful for, let's say if you are building a kind of a lateral C, ordinary square or anything. But the limitation of the continuous variables is that you cannot use it for many of the tests. Okay, so you have to recode it. Then there is a facility, those who are using in SPSS or those who are beginning the exercise, because SPSS is very user friendly in that sense. Otherwise, Tata and others, you have to write lot of syntax and all this. So those who are not familiar, there is lot of time you have to invest to understand the scientific language of this program. Though the recent Tata versions have already come with this kind of inbuilt options, but still generally the SPSS is more user friendly, especially those who have no background from statistics and not from economics background. You can also use to generate the descriptive statistics from this. So the record into different variables you can go. Then what you can do, you have to take the intended variable which you want to record. Suppose I want to record the household income, which I have named income. So I will put that I want to record this variable. Then I gave a new name. So this is the HHI coded is new name of my variable. Then you go to the values. In these values you have to give that which are the values, means how you want to distribute. You can choose, let's say I want to distribute my entire distribution based on, let's say, mean. So something which is distance from the mean, let's say 25% of the mean or 50 of mean, the mean is in one category, or even median. those who are below the median and those who are above the median. So in n number of ways, you can actually now group this huge data of income. It is only 700 observation, 700 plus observation, but if you let's say 7,000 or 70,000, so these coded things will help you to make these variables, and especially it will help you in your descriptive analysis. So now once the income is coded, you can also cross-tab across the social group, across the religious group, or across the, let's say, land holding. I have already created a variable both in continuous and coded, which is land holding, or gender. So in different ways. See, one variable, only combination of two variables are giving you so much insights. So that helps you to build a perspective around that what you are looking at. So, and another thing which is very, very important, I told you, the sampling. Many people in real world actually, when you will go out of a classroom and enter the field as academia or a consultant or statistical quantitative specialist, you will first come across a constraint of budget and time. So many times your sample is given, you want only 5,000 household survey. But otherwise, what is the scientific quantitative inquiry involves that what is the appropriate sample size one can, which is needed for an inquiry. So it is a very simple formula. There are n number of formulas you can get online, but those who are very confident on their understanding and have clarity of the issue, their universe of research, then the sample, the strata are in the universe, so they can actually go for this kind of the simple formula to fix a sample size. Suppose, let's say, if I want my confidence interval 95% and a standard deviation of 0.5, so and a confidence margin of error plus minus 5%. So using this formula, actually you can get a sample size. So somebody will, can ask here, if this is the formula for this, then is this important? Means will this lead to that any study I want to carry out, the sample size should be 385? Answer is no. The thing will be changing if suppose there are your standard deviation and your confidential marginal error and confidence level, if you are changing, this figure is going to be changed. But generally, you remember in any statistics thing, they say that anything less than 30 is a small sample case. They say, and anything more than 50 is considered a large sample. That's why many people actually not convinced by the argument that the sample size has to be sample size has to be determined in following a particular formula. Rather, what they mix, they call it mixed method, that okay, I have a target based on the budget, I have worked out how much household I can cover, so they do backward. So given the budget and time, they backward they do, but then they ensure that how much minimum sample I should collect, so that my sample collected in that fashion will give all the statistical results I want. So another way is to determine how much sample you can do. You can look at, let's say if I take an example, only two variables, let's say gender I am taking, then I am taking also the social category. Let's say here it is 2 group and that is 4. So how many matrix you can imagine? 2 into 4. So there will be around 8 cells in that. Okay. So each cell in matrix you have to have at least 5 observations. Okay. Any sample statistic initial phases you will get this thing. That is also very important. So in that way, suppose you are dealing with 100 variables and you have number of categories you can look at. So just multiply it. So with 5, So that means, let's say 100 variables, and total number of, let's say the categories you are getting, let's say that is also another 100. Okay? Now, if you have a budget and you have time, then you ensure that in that matrix each cell have 5 cases. So the total number which you will get, that will be your ideal sample size. But otherwise, many people actually practically, I don't know how many of are doing PhD research based on field data. How many? So many of you. So how you decide your sample size?
So it's depending on population, finite and infinite population based on some formulas we calculate.
So how much you reached the sample size?
So for me it was around 800, but then 250%.
How you reduce it to 50%?
That I have to discuss.
Okay, so that is the constraint. That's the economics. Okay, and time. Okay. Given your fellowship and duration of everything, you have to finish. So if I take let's say one household at least 5,500 cost. So 800 sample means into 500, how much it will come? Eh? 4 lakhs or 40,000? 4 lakhs. So she is doing the work of a project for 4 lakhs. Okay. So anybody else who has used this kind of formula, can you just quickly go? We will not spend much time on it. How you have fixed your formula for your research, for your doctoral thesis? How you have done it? Those who are using secondary data, forget, I am not educated, but those who are doing hard, that you have. So how you got it? What is the sample size you have?
400.
400 you got. And what is your inverse? What is it?
My inverse is Kolhapur district.
Kolhapur district sample. Then you reduce to 400.
400.
So that 385, that formula also is broadly sum. So that's what I am saying. My purpose was saying that any formula you use, so anything around between 300 to 400 is generally considered kind of a ideal scientific sample. But with that, then when you reach to that kind of number, then again you have to redistribute across the different strata. So that's why I am saying that this sampling is always, many people say my sample is scientific sampling, but always there is a purposiveness. Now you have to be very clear that how and why you have combined the both, means the purposiveness and the randomness. So these two you do and you reach to a sample size. So from that sample, now whatever we got basically in statistics, these are the two very important concepts. See, some of the things I am telling extempo, maybe you are finding that I am not, it's a little bit some flow issues or something, but always you can, if you are thinking that some clarification needed, you intervene. So the two things are very important in statistics. Many people, many papers, n number of papers, anything you pick and bring to me, you will find that the first confusion in the paper is about the statistic and the parameters. So whatever data, those who are using it very rigorously, they must be aware of it. Those who are planning to do, first focus that many of the even reputed journals also ignore this aspect, but technically you have to justify your presentation which you are talking about parameter or the statistic. It's a simple way. I am telling there are a lot of properties around it, but you remember when you are saying parameter, you are talking about the entire population. But when you are talking about these sample, I mean statistics, you are talking about your sample. Then sample, which sample? It is the scientifically drawn sample, not the other one, the qualitative samples. Observation method or convenient sampling, snowball sampling, those kind of things where that cannot be statistics. Okay? But now when we go towards the end, we'll find some non-parametric test in statistics have come to facilitate the qualitative observations. But still, those statistics in strict sense we cannot call them, okay? Because it is not drawn through proper random sampling method. So this is, you have to be very clear, because many of the, actually Sidhu has suggested me, and I am also realizing that many of the things where theory, formula, equation and all, that is, we are designing most of the course basically from the user perspective, final use. But there are a lot of mathematical modeling and other things have gone. Those who are interested, I am sure you must be definitely following them. So the first thing, in the statistics, you remember, the basic thing is that the mean. Many people, okay, mean to kya hai? Number of observation total karo divided by number of, but that mean is very important. The way you choose the mean, because mean invariably takes all the observations. So if your data has extreme values, few very small values, few very large values, so you get some mean, and you will find that next of months our entire modeling exercise and everything will be determined by that mean and dispersion from the mean, which is standard deviation. So it will give rise to normality issues, and it will, but it will happen only for the continuous variables, not for the categorical or ordinal ones. So when you are dealing with, especially those working in agriculture, industry, there is output, productivity, income, market price, these kind of things happen, and you are collecting data. You have to be very, very careful. Even if your 400 is very well defined, and you have to, but that 400 is leading to extreme variations. So then there are logarithmic transformations and other things. Even the easiest way, I will tell you, many people don't use it, thinking that they will miss some observation. The easiest way is that a truncated mean. Truncated mean means you take out the extreme values at two ends. Then remaining, whatever is remaining, that will give you a more stabilized pattern than the entire distribution. That is the easiest one. Other one is, many those who are doing agriculture and industry and monetary subjects, if you are engaged with or export data, you deal with large volumes, lakhs of metric tons and all these kind of figures you deal with. So you go by logarithm transformation and other techniques. But the thing, what is the purpose of doing it? Doing it to, you want to get a representative but stabilized mean, which represents your distribution. If the distribution, your representation is not stable, then based on whatever statistical models you do, simple or very complicated models, that will only give you erroneous results. So that's why the mean, while calculating mean, median, of course, the central point of the distribution, you cannot do much. Mode is the observation around which most of the individual values are concentrated. So you cannot, these are positional values, positional central values. So you cannot do much about it, but you can work with mean. So, and mean is the base from where you carry on whatever test you do, from single univariate test, normality test to different kinds of regression, whether in cross-section data or panel data. So first, if you have doubt that my mean is not consistent, my mean is not representing, then you have to see the way I have collected the data, and you work again backward, that how I have collected my information. And there are techniques, I will share some of the references how to correct the distributions. You can still use the correct the distribution, go ahead. Let's see. So then the dispersion already I have talked about, so we will not spend much time. But then again, when in dispersion you use this interquartile range or the coefficient variation kind of thing, it also gives lot of insight into it, the quality of the data you have collected. So especially the interquartile range can be very useful, like I was talking about coding the variable, continuous variables. So this interquartile range will be come handy. So if you can take, let's say, poorest 20% in income, middle 40%, or the upper 20%. So this kind of flexibility it will give, and that will add lot of insights in your distribution. So this is the kind of measure of dispersion. These are the formulas. You can look at from any book or in this PPT, it is already given. So I will just rush through few of these coming slides. We have already talked about it. Then the another thing is the standard deviation. With mean, I told you that many of the formulas, if you see, you will see these two things, whether you are calculating a parameter or you are calculating a sample statistics, is the mean and the dispersion. And dispersion measured in the standard deviation mainly. So that we are using with the number of observations, and these 3-4 things are very crucial. You calculate any kind of simple to very complicated statistics. Okay, statistics or parameters. Remember, when I am telling statistics, I am talking about a sample, representing sample. When I am telling about parameters, I am telling about the population. Okay, so again, based on that standard deviation for population and sample, there will be little variation in the denominator. When in population, if you are looking at the standard deviation, entire population is considered. But here in sample L-1, that means the total sample is the total number of observation minus 1 is your denominator. So your denominator, since most of the things we are doing in our statistical packages, you get, it is basically a machine kind of thing. You put some input and some output will come. But then, as I told you, you know the data which you have entered in those packages, whether it is a population or it is a sample. Accordingly, your interpretation will be per population or the sample. Many, these are the things, everybody can do the statistics. It's not a big thing. Even many people are coming from, let's say, into market research from various backgrounds. They don't have time. They only learn these basics. But you find that from my personal experience, I have seen that their interpretation, even if their frequency, even if their mean, dispersion, everything, when they clarify, they have more clarity than many of the kind of people who pursue actually from their graduation days. Because why? Because they learn few, but they learn those few with better clarity. But sometimes we learn many things, but then we fail to understand the basic properties of each of these things. So that part we should not do in statistics. When I teach statistics, I know that many of the things people are already in some way they are familiar, or they can be familiar because as they progress in the course, during their course they will get it. But they always forget these basics, that why we first came into the picture, why we are planning to use statistics in our inquiry. Because there are disciplines like sociology, then this anthropology, so many they will also bring out lot more insights without using numbers. But you will see that over the years, some of these disciplines have also accepted the numbers. Why? Because they understood the power of the numbers. Okay. So from this sample, the sample data which you are given, I have given to you. I have calculated this one. So you can get it from the sample. If you have, you will get the same table. If there is little variation, don't worry. Some 1 or 2 observations I might have missed for you in this file. But what it is showing, I have taken only 2 characteristics. One is gender of the respondent, household, and who is the household head, and what is their agricultural waste they are receiving. So 4 questions I have asked. Quickly, just tell me, any one of you can tell me what is the major reading we are getting from this, which will qualify that we have carried out a statistical exercise. Of course. So I can say that both my central tendency, that mean as well as median, which is a positional value, shows that men have higher wage rate than women on an average. Okay. So this is daily wage rate. Okay. Then the standard deviation. What insight it is giving?
Variation in female wage is less compared to.
So is it a good thing?
No.
It is not a good thing. Because women in general tend to get lower wages. But men, depending upon their skill set or maybe their experience in the work, maybe for the similar job, they are getting a higher wage rate. Okay? So that is one insight we draw. Then, of course, minimum, maximum, that is some of the households. I have intentionally put 0 because later when we go and see these charts, we will see that if our observation consists of 0, what it does to our analysis. Okay, so purposefully it is kept. So, can you tell me, from looking at this data, is this data skewed?
No, sir, it is right skewed.
Huh?
Right hand skewed.
Okay. Why? How you have concluded?
If you take a median in middle value, then it's tended to more to right side.
No, how you visualize? Is there any information from this, whatever I have said, that you can conclude that it is, the data is skewed?
No, sir, I'm just taking that all are the symmetric values.
Yes. So, one can do that. If your median is less than mean, what it says? It will be
Negatively skewed.
negatively skewed. Yes, that's the answer. That's how you are having some interest at least. So, without doing anything, you can at least write one page from this. And all those, your propositions which you have drawn. And I am telling you, especially focusing on those who are not familiar with statistics. Based on your numbers, because this is number, nobody, even if you have a qualitative observation, you have frequency, still you can make this kind of positional values, and which you can draw very powerful comparison. Of course, somebody will ask, the mean is different, this mean is almost double than the female, is it statistically significant or not? So those are kind of questions. But preliminary you are able to show that I am deep insight into my data, and this is not based on just observation but with it supported by the numbers. Okay? So quickly we'll go. So this is how a normal distribution looks like. Now you look at it. So this is actually I have taken from some other presentation. You can see that what this data is showing. Overall, it is showing a positively skewness, but it has lot of fluctuations. Okay, I was talking about. So if you do advanced analysis from this kind of data, a modeling or something, regression, then most likely you will face a problem. So that those peaks has to be trimmed. So either you use the trim mean method or you use any logarithm method. So you do, but this data has to be smoothened. So this is showing that lot of people actually are bottom of the central position. So there is a huge concentration below. So you can you imagine what is happening in this? This is context of world population, but in Indian context we will say that we come across the news, no, that bottom 40% of our population have only 20% of the share in the GDP. So those kind of, see, these are the small things, but you can make very powerful observations. So that's what we just quickly, it's good that you people are really imagining that how the median's position vis-a-vis mean will give what kind of a shape. Okay? So in our case, what happened? Our median was less than the mean. So we would have get this skewed to left distribution in our waste data. Okay? Clear? So now the another way that nowadays this is people like pictures very much. So pictures you have to show a lot of pictures. So this kind of information what are we presented in a tabular form. If you choosing to present in histogram, just a histogram we saw sometimes back. So the you use this histogram, pie bar, scatter plot, addition. You remember one thing that maybe another file I will put and I'll show you in the next class in the practical.